Good morning, students. So today we'll start with a new chapter in Pointer, which is known as dynamic memory allocation. Now, before going to this dynamic memory allocation, we have to know how the memory management works. Okay, in C or in any language. So when you declare a variable using a basic data type, suppose integer a, that means a is a variable which is allocating some memory by how? With its data type. What is the data type? It is integer, and the element is placed inside the stack. So when it is allocating some element inside the stack, what is the size, or what is the memory location, or what is the actual size it can take? It is 4 bytes or 2 bytes. Okay, so through this we can use size of function. Okay, take an example of memory management system. Whenever we go for it, I have given an example: int main float x. Printf the size of float is %d comma size of x. Here I have given %d. That means whatever we are going for it, float x or anything, I am checking the size of it. So size of x is 4 bytes. So here I am giving for the output 4 bytes. That means it can take 4 bytes of memory inside, or 4 bytes inside the memory location. Now, before going to the what is dynamic memory allocation, or what is this thing, memory allocation can be of two types. One is called static memory allocation, second one is called dynamic memory allocation. Static memory allocation is quite clear. Suppose we are writing integer a4. A is a variable consisting of 4 elements maximum, and the data type for it is integer, right? And dynamic memory allocation means whenever we are running, or whenever we are accessing some variable during runtime of the program. When you are running the program, we think that no, if the size was large enough, then I can easily take the value, or I can easily place more elements inside it. So how can I take? By using dynamic memory allocation. So static memory allocation is allocated during compile time, and dynamic memory allocation is allocated during runtime of the program. In static memory allocation, memory cannot be increased. Yes, it is quite clear. Integer a4, you cannot increase the size, it is fixed. But in dynamic memory allocation, you can execute the program by increasing the size. Okay. And static memory allocation, I have given the example of array, and dynamic memory allocation there is an example of linked list. Linked list is a linear data structure. Okay. Now come to the next part. The most important part is dynamic memory allocation. What is this dynamic memory allocation? So when declaring a basic data type of an array, when you are declaring integer a or integer a5, the memory is automatically managed, right? However, there is a process for allocating memory which will permit you to implement a program in which the array size is undecided until you run your program. So take an example: you are moving to a marriage ceremony, and you have gone to the counters to take some food. So previously you don't have any idea what are the elements, or what are the menus that are present, right? When you are viewing the element, then you have chalk out a plan that I will take this amount of food inside me, so that I can take or go for many items inside, my favorite items inside me. So what are the things? It starts with naan puri or chana bhature, then it will go for mixed fried rice, then it will go for mutton biryani, then it will go for mutton kosha, then chicken chop, and then it will move on up to the dessert, right? So you have seen that biryani is my favorite, so I can take it easily. So during runtime of the program, you are planning inside yourself that if I take only one naan puri and small amount of chana bhature, I can easily take one plate full of biryani I can take. But if I am taking 2 naan puri and chana bhature, then I have to take the biryani amount small enough, as well as the other mutton items or the chicken items. So you are chalking out the whole thing in your mind, that how I will manage the memory. This is the idea of dynamic memory allocation. Now in the dynamic memory allocation, in the header file stdlib.h, or the standard library file, there are 4 types of functions present. One is called malloc, calloc, realloc, and the free. Malloc, calloc, realloc, and the free. These 4 types of memory functions are present, and these are the parts of the dynamic memory allocation. Okay. So during read, I have to change my memory size. So what is the malloc? Malloc means memory allocation. It allocates a single block of memory. Calloc is called contiguous allocation. That means it will take multiple blocks of memory. And third one is realloc. That means I want to reallocate the memory that is already occupied by using malloc and calloc functions. And the last one is the free. That means I want to empty the position that I am now holding after my job is over. These are the 4 functions that are present in this dynamic memory allocation. Let us take an example. The first one is the malloc function. As I have told you, malloc is called memory allocation, and it is a single block of memory, right? So the syntax for it, ptr equals to cast type star malloc byte underscore size. Cast type means typecast. Changing of the different data types or changing of one form of data type into another, there are 2 ways of changing it. First one is called type conversion, second one is called typecasting. Type conversion means it is automatically converted from integer to float or float to integer like this. If I have to forcefully convert a float into a double, then I will write it as typecasting, forceful conversion of the data type. Here I have written there, I don't know that what type of data I want to change, so I am writing here typecasting. Okay, typecast star. Here I am writing ptr equals to integer star malloc 50. Integer star means ptr is a pointer variable. It is allocating, or a memory space of 50 bytes is allocated. Size of byte or size of memory is 50 byte is allocated, and which is pointed by this ptr. So ptr is a pointer of the cast type or the typecast. The malloc function returns a pointer. Why it will return a pointer? To the allocated memory of byte size. To the allocated memory of byte size. Why it is pointing to it? Because it will show that the memory is pointed by ptr and it is allocating an element of size 50. Clear? Take an example, it will be much more clear. Here I have taken integer star ptr, so it is quite clear from pointer that ptr is an integer pointer variable, and ptr equals to malloc 15 into star 15 into size of ptr. That means there are 15 elements present, and what is the size of the 15 elements? That will be pointed by ptr. Now if ptr not equal to null, if ptr equals to null, that means nothing is pointed, it will give an error. But if ptr not equal to null, that means it is not pointing to any pointer, then we can say that yes, move to the next element. That means I will increase ptr plus plus or star ptr plus plus. Here I am writing star ptr. Here I have written star ptr plus 5. Star ptr plus 5 means it will point to the 6th element. What is the 6th element? It is 480. So I am getting the value of it. Okay, here the output is 6. Clear? This is an example of malloc. Come to the next thing is the calloc. I have told you calloc is called contiguous memory allocation. And as I have told you is in the previous slide, it consists of a multiple blocks of memory. So in malloc, take an example of malloc as a small matchbox. Single block of element, a number of elements or 15 elements are present, 15 into size of the block. How many elements are stored? 50 elements are stored. Here 15 matchboxes are, or 15 matchsticks are present in what? In a single block of memory. 15 matchsticks are present in the single block of memory, and it will go for the total size which is pointed by ptr, right? Clear? Now we can say yes, say the 6th integer is 480 or the 6th element is 480. I can take it from here. Okay, but for this calloc is a contiguous block of memory. That means we are taking a large homelight matchbox. You have seen a large homelight matchbox. There are 2 compartments. We are pointing the elements starting from here, then we are going to here, then we are going to here in this way. So it starts from our initialized to 0. Initialized to 0, then 1, then 2 in this way. So here the formula is same as that of ptr equals to cast type or typecast. That means integer star calloc. Only in malloc we have written one thing is the size of the block. Here I am writing the number of blocks, that is n, and the size of the block, size of each block, right? So n is the total blocks or total number of blocks present, 2 blocks, and what is the total size of the blocks. Total size of the block means it depends on the elements. So it is quite clear that calloc function is used for complex elements. Clear? Okay, so take an example of calloc. Yes, again the same process. If ptr, what I have told you in malloc is if ptr equal to null, that means it is pointing to nothing, so it is giving an error. If it is not equal to null, then it will go for this else part, increase the pointer variable, and here I have used that how many elements are present and add the elements. So I have used their sum equals to %d. Okay, that means it will add the element, and finally it will free the pointer. So this is the example of calloc. Now coming to another function which is called realloc. Realloc means I am reallocating the element. Reallocating means I am expanding the current block while leaving the original content. I am not disturbing the original content, it remains the same, but I am making the size a bit larger. Suppose you are entering into a C lab. There are 30 students, which can be where there are the intake of that lab is 30 students. Now outside it there are total 35 students. So 5 students are more. What should I say? That you should go home? No. Instead of doing that, I am placing 5 more chairs inside the room. Right? If I insert 5 more chairs inside the room, then 5 students can easily sit there. So now my carrying capacity of the room is 35. This is called a reallocation. That means pointer will point to a new size. Previously it was 30, now I can say I can allocate 35 students inside my room. This is called the reallocation factor. Here you can see in the program, here it is written malloc 10. That means the size of the block is 10. Now when I am going for realloc, that means I am incrementing the size of my block, it becomes 20, and I am concatenating. Here I am using a function concatenating, means I am inserting 5 more students inside that particular room, it becomes 35. Clear? This is the function of realloc. Next one is, or the last one is called free function. Free means you have your lab is over, all the things are given to the students, and you can say now you can go home. That means this lab will be allocated by next other person. Suppose the first person who is using the lab is C. The second person who is utilizing the same lab will be, suppose, microprocessor. Okay. So after clearing of the class, when all the students along with myself are moving out from the room, that lab is now allocated by whom? By the microprocessor teacher. Now it depends on him or her that whether he will take 35 students, 30 students or 25 students. That depends on him or her. So here I can change my function. This is called free function. That means when my job is done, free the memory allocation. So the memory of variables is automatically deallocated at compile time. In dynamic memory allocation, you have to deallocate memory explicitly. If not done, you have an encounter. I have to clear it. Explicitly means yes, you have to clear the item. Yes, hence you are writing at the last of the program, you are writing there free PTR. The PTR is a integer pointer variable which is pointing to 10 elements of size something, and you are checking which position or which location will be the element. Now when you are moving out from the room, you have to say that which particular room you are using and want to free PTR. That means free whom? Free that block which is pointed by PTR. Free the room which is pointed by PTR. That means you are explicitly defining that you have to empty or you have to clear the room for further use. This is the use of free function. It is necessary. Otherwise, it will give error. That means overwrite will be done. I haven't said anyone that the room is cleared. So the other person is standing outside the lab thinking that yes, the lab is already filled, but it is already empty. That means error will occur. Misunderstanding. Clear? This is the use of free function. So by freeing the memory in your program, you can more available for use later. Yes, if I free in time, I can use it later. That means that same person can also cooperate to use the lab for further use for any other person. Clear? This is the free function. So up to this is your dynamic memory allocation. In your syllabus, dynamic memory allocation is not there, but it is very much needed for the programs. Just read the whole video and go through it. If you have any problem, you can ask me in my discussion forum, or through phone calls. Okay, so go through it. I'll go for some small things and stay tuned for the next slide. Thank you.